Okay, to change 0.4 recurring to a fraction, let n equal 0.4 recurring. Now there is one recurring number, so we're going to times by 10 on both sides. So we're going to get 10n, and we're going to get 4.4 recurring. We need the recurring fours to line up. So then we need to subtract both of those equations, the bigger equation from the smaller, by the smaller equation. 10n minus 1n gets you 9n. The 4's recurring cancel each other out. 4 minus 0 gets you 4. To get rid of the times by 9, we divide by 9 or over. Now check your calculator. 4 over 9 equals 0.4 recurring. Now let n equal 0.123, and the 2 and the 3 are recurring, not the 1. Okay, so this is two recurring numbers, so that is going to be 100n. Now, with 2, the decimal point will be between now. It'll move 2 places between the 2 and the 3, so it'll be 12.3. Then it recurs again, 2 and 3, and that'll keep on recurring. So we're going to put the recurring there so they line up again. Again, we're going to subtract. 100n minus 1n is 99n. The recurring bits cancel out. 12.3 minus 0.1 gets you 12.2. Get rid of 99, so we divide or over. Now we can put that into our calculator, 12.2 ABC 99, and the calculator will simplify it for us to 61 over 495. And check that answer and you'll get 0.12323. Alright, circle the rational numbers. Okay, whole numbers, fractions, recurring decimals, or any square roots that can actually become integers. Okay, so 4 is definitely rational. Root 2 is not. Put that in your calculator, it'll get an ugly decimal. Fraction, recurring decimal, pi is not. Square root of 25 is 5, so that's fine. Fraction, that's fine. The cube root of 64 is 4, so that is fine. And 3 root 7, or root 7, is definitely not. Okay, to simplify we need the square numbers. So 1, 4, 9, 16, 25, 36, 49, 64, etc. Okay, so 50, biggest square number is 25 by 2. Now the square root of 25 is 5 root 2. 48 is 16 by 3. 16 square root is 4, and you're left with root 3. Now the 5, I'm just going to ignore for now. 8 is 4 by 2. Square root of 4 is 2, and the root 2 stays. 5 2's are 10. Okay, addition and subtraction must do like terms. So we have like terms. Add the integers, we get 5 root 5. Okay, 18 and 27 are unlike, but we can simplify. So 18 is 9 and 2. Square root of 9 is 3 root 2. Multiply by 4 gives us 12 root 2. Take away. Now 27 is 9 by 3. Square root of 9 is 3. Times by 3 gives us 9 root 3. They are unlike terms, so that is it. Okay, 150 is 25 by 6, so that it will be 5 root 6. Times by 2 gets us 10 root 6. 8 is 4 by 2, which is 2 root 2. Times by 3 will get us 6 root 2. 50 is 25 by 2. Square root of 25 is 5 root 2. Times by 4 will get us 20 root 2. Now we have like terms there, so we'll still have 10 root 6, and plus positive 6 minus 20 gets us negative 14 root 2. Okay, 6 times root 10 is just simply 6 root 10. Alright, E. Multiply the integers first. 5 sixes are 30. Third, 8 by 2 is 16. Square root of 16 is obviously 4, which gets us 120. F. Division of the integers first. 28 divided by 7 is 4. Root 3 divided by root 3, they cancel each other out. Now, when we are squaring, square the integer first. 3 squared is 9. And multiply, square the third. They cancel each other out, and you're just left with the number in the 9 threes are 63. Okay, 5. I would multiply and divide first and then simplify if necessary. So, top line, 2 by 3 is 6. 5 by 6 is 30 over 4 root 3. Now, 6 and 4 can't divide, but they can simplify. 2 goes into both. 3 and 2. 30 divided by 3 is 10, so it will be root 10 still at the top. Okay, B. 2 sixes are 12. 8 by 5 is 40. Now that can be simplified, but we'll wait. 3 twos at the bottom are 6. 10 twos are 20. 12 divided by 6 is 2. 40 divided by 20 is 2. Okay, rationalise. Now we need to make that number a whole number. So we times by itself. What you do to the bottom, you must do exactly the same to the top. 2 times root 5 is 2 root 5. Root 5 times root 5 times by itself is just 5. And they can't simplify. Okay. This one, to get rid of the root 7, we times by root 7. What you do top, bottom you do the top. So we get root 5 times root 7 is root 35. Root 7 times root 7 is 7, times by 3 is 21. Okay, C. Now, this is where we have to times by the conjugate. Now, the conjugate at the bottom, because it's a plus, will be 1 minus root 2, and do exactly the same at the top. Alright, now 8 times both of those will be 8 minus 8 root 2 over. Now, you can do double rainbows, but again, the middle will just cancel each other out. So all you need to do is do 1 squared, which is 1, root 2 squared, which is 2, and there must be a minus in between. Okay, so that will get you 8 minus root 8, 8 minus 8 root 2 over negative 1. Now you can't really have a negative on the bottom, and you don't need the 1 on the bottom, so that can just come up the top, and in brackets, so just have the negative at the front. Okay, expand and simplify. Okay, rainbows. Root 6 times 2, integer and surd, is 2 root 6. Root 6 times root 6 is 6, and there is a minus. Unlike terms, so that's it. Okay, B. Do integers first. 2 threes are 6. Root 3 times root 2 is root 6. 2 times 4 is 8, and you have root 3, and there is a positive. Okay, now you can do double rainbows here. Root 6 times root 6 is 6. Root 6 times negative 4 gets you negative 4 root 6. 4 times root 6 gets you positive 4 root 6. And positive 4 times negative 4 gets you negative 16. Now those two cancel each other out. 6 minus 16 is negative 10. Okay, so when we square, let's write the brackets again. So we use double rainbows. Root 5 times root 5 is 5. Root 5 times negative root 2 is negative root 10. Negative root 2 times root 5 is negative root 10. And negative root 2 times negative root 2 gets you a positive 2. Okay, so we get 5 plus 2 is 7. Minus 1 root 10 minus 1 root 10 gets you minus 2 root 10. Now 8 just simply means it needs to be written in this form. So let's simplify this first. 2 plus 6 is 8. Now root 125 can be 25 by 5. And square root of 25 is 5, and you'll have the root 5. Now, this is in the form of that now. So the number representing the A is 8, and the number representing the B is 5. This 5 here. Okay. Now that doesn't have a denominator, so what we're going to do is rationalize this denominator by times it by itself. So we get root 2 times root 2 is 2. Negative 1 times root 2 is negative root 2. Root 2 times root 2 is 2. Okay, now, because again this doesn't have any denominators, we're going to actually split this fraction up. So it's 2 minus root 2 over 2, or it can be split as 2 over 2 minus root 2 over 2, which is the same as 1 minus a half, because there's actually a 1 there, root 2. So when we look at this, the x, the number by itself, is 1, and the number in front of the root 2 is minus a half. Now, diagonals measure 8 and 12, so therefore with a rhombus, you should know the rhombus is 90 degrees, so we only care about this right angle triangle, so that would mean that this has to be 6, because it's half of 12, and this has to be 4. Okay, now if we use Pythagoras, x squared equals 6 squared plus 4 squared, which gets us 36 plus 16, which gets us 52. So x will be the square root of 52. And 52 can be divided by 4 times 13, which gets us 2 root 13. Now, the perimeter will be 4 of those, so therefore the perimeter will be 4 lots of 2 root 13, which is 8 root 13 centimetres, because it wants it in exact.